We have one more scientist who we're going to talk about in terms of the history of astronomy. And this one figured out that the Earth rotates. Remember that the ancient Greeks thought the Earth didn't rotate and that it was the sun moving across the sky. So there are two Earth motions that I want to distinguish in terms of what we call them. The first motion is called rotation. And rotation is spinning on an axis, an imaginary axis. And so here is a cartoon showing how Earth rotates on an axis. And that gives us our days and our nights. The other motion is called revolution. And we revolve around the sun. And that takes a year. This video is going to talk about rotation. In 1851, a French physicist, Leon Foucault, did a very clever set of experiments to prove that the Earth rotated. And he did this by using something called a pendulum. So what's a pendulum? So a pendulum is a mass that hangs from a string. And so I often use my PCC keys on their lanyard. And it swings in a plane. In other words, it swings in one plane. It doesn't swing like this or this, right? It swings in one direction once I let go. In fact, that's Newton's first law again. It's not going to change direction unless it's acted upon by an outside force. Okay, so imagine you're at the North Pole and you have a pendulum that starts moving. Let's say that pendulum is over some sand and it drags a little mark in the sand, so you can actually see the direction that the pendulum is going. So as the Earth rotates under this pendulum, what you're going to see in the sand is a change in the direction that the pendulum is swinging. And because the pendulum can only swing in one plane, that must mean that the Earth is rotating underneath it. So this is supposed to illustrate what I'm talking about. Here's that pendulum at the North Pole. This is where it's fixed at the top, and this is it swinging. And then the Earth rotates under it, so you can see that North America here has rotated to our right. And the pendulum is still swinging in the same plane, but if you're on the Earth, it appears that the pendulum has changed its direction. And I think this is easy to imagine at the North Pole, but this is true no matter where on Earth you try this. And so pendulums are now very commonly set up in museums. Here's a very large one that's set up, and this is the mass, and the string goes up here. It's actually kind of a wire. And if you think about it, when the pendulum swings and the Earth goes around 24 hours, you can actually kind of make this into a clock, right? So that's what they've done here. They've got noon, and they've got the times written out, because the Earth will turn once every 24 hours and you can use it as a clock. There's a great one at the Griffith Observatory if you've ever been there. Some more modern evidence that we have are time-lapse photos of stars. So here's a time-lapse photo of the night sky. The stars look like they're spinning, but of course it's the Earth that's rotating. And what's in the very center here of this spiral of stars? Polaris, the North Star. And remember, the North Star is directly over the North Pole. So if you were at the North Pole, this star would be directly overhead. As you go lower in latitude, the angle of Polaris above the horizon is less and less. So let's say, for example, that the angle between the horizon and Polaris here, let's say it's 35 degrees. Well, that would mean that you are at 35 degrees north latitude. So again, this is another piece of evidence that the Earth is rotating. Coming up next, revolution and the rest of the Earth motions that we're going to talk about.